Hello everyone, this is Chandrasekhar Balla, the assistant professor in mathematics. Let us learn how to define an echelon form and find its rank. First, we learn about the definition of an echelon form, row reduced echelon form. So, a matrix is said to be in echelon form if it satisfies the two conditions. The condition one is if any row is there, it must follow the non-zero row. For example, consider a matrix A, and in this matrix the row 2 and row 3 are 0 rows and it should follow the non-zero row. So that can be written as the third row and fourth row. So if any 0 rows are there, that should follow the non-zero row. Next, the condition 2, the number of zeros in each row except the first row should increase. For example, you can see that this is the matrix A. The number of zeros in the second row are 2 and the third row is a 0 row and the fourth row is 1. So now number of zeros in the third row is a 0 row, so it should follow the non-zero row. So now the row 3 is reduced to the row 4, and next now see that the number of zeros in each row should increase except the first row. Now 1 0, 2 zeros, 3 zeros, and it may be 0 or may not be 0. So this is the structure for the echelon form. So some important results of the echelon form, that is the number of, so we will find the rank of an echelon form by using the number of non-zero rows. For example, so this is the matrix A, and now we can count, it is in the structure of an echelon form as it is the first row, first element should be non-zero and the number of zeros in each row should increase. So it is in echelon form. Now we can find its rank. The number of non-zero rows will gives us the rank here. That is non-zero rows, one non-zero row, second is also non-zero row, these two are 0 rows. So we'll count only non-zero rows. Non-zero rows are 2, so its rank is 2. Next, in this echelon form we have to use only row operations. So that is the reason we'll write it as a row reduced echelon form. Next result. So in this echelon form, the interchange of the elementary operations does not affect the rank. Let us learn with an example. So consider a matrix A and how to reduce the matrix A into echelon form and find its rank. So this is the given matrix A. Now, so using the first row first element, make all other rows first elements as a 0. So for that, write the operations. R2 implies R2 plus R1. R3 implies R3 minus R1. R4 implies R4 minus R1. Reduce the row operations. R2 implies R2 plus R1. So write the first row as it is 1, 1, minus 1, 1. R2 plus R1, 0, 2, minus 4, minus 2. Next, R3 minus R1, 0, minus 1, 2, 1. R4 implies R4 minus R1, 0, minus 2, 4, 2. Next, using the second row second element, make all other rows elements 0. For our convenience, we are making the changes in the R2 and R4. So that can be written as R2 implies R2 by 2, R4 implies R4 by 2. Take out 2 common, so equivalent to 1, 1 minus 1, 1, 0, take out 2 common, 1, minus 2, minus 1, 0, minus 1, 2, 1. Again take out 2 common in R4, minus 1, 2, 1. Now using the second row, second element, make all third row and fourth row elements as a 0. For that, write the operations. R3 implies R3 plus R1, R2. R4 implies R4 plus R2. Now compute the operations. 1, 1, minus 1, 1. 0, 1, minus 2, minus 1. 0. R3 plus R2. 0, 0, 0. R4 plus R2. 0, 0, 0, 0. The matrix is equivalent to. Next. So according to the definition of echelon form, the first row, first element should be non-zero, and if any 0 rows, that should follow the non-zero row, and the number of zeros in each row should increase. So now it is in the echelon form, so we can find the rank. The rank of a matrix in echelon form is defined as number of non-zero rows. Number of non-zero rows. Non-zero rows. Now count the number of non-zero rows. The first row is non-zero and the second row is non-zero. So therefore the rank of a matrix is equals to 2. Thank you.